Welcome back to the series. We are tying off the loose ends of the project, and I just wanted to show you some insight in terms of the transformation processes that we are applying to RHS data to prepare them for visualization purposes. And for that, we're using dbt as our main transformation tool, and we're going to be running it against the BigQuery data warehouse. Something that we've amended inside this repository is we're starting to split things off into separate repositories, as it makes things a bit easier to deploy in some scenarios. So for example, we've pulled out the dbt models and we've put that into a dedicated repository, and that is going to make it much easier for us to orchestrate things on Airflow, and you'll see that in a moment later on in the video. So we'll start things off by going into the dbt chess repo, and I'll give you some insights in terms of how we're modeling the data. So you can see we have a raw data landing zone, and this is going to be the ingestion pipeline where we're running our API requests from Python and landing them into BigQuery. However, this data is not going to be specifically prepared for providing KPIs and metrics, so we still need to rejiggle that data around to put it into an appropriate format. Hence why we have a staging and aggregate table following on going downstream. We also have an opening games table, which acts as a mapping table for all of the chess variations that are happening in the different chess games. We can aggregate things into different chess families, and hopefully that makes it easier to spot patterns in the data. Okay, someone at the door. Always someone at the door. Okay. Where were we? Can't remember. I think we'll just go into the next bit. So I think we're going to go on to the dbt models themselves to give you an idea of how we're transforming. So we'll dive into the models. Let's have a look. Start with the universal data set. We've got this calendar table. And this is providing all of your date descriptors for the different date periods. So determining the month of the date selected, the quarter, the week, etc., etc. And in addition, we are supplying a series of Boolean flags which enable you to build out filters for your KPI and metric calculations in your front-end dashboarding systems. And this gives you a little shortcut in terms of building those metrics out. So that's what we have. And in terms of the staging tables, we're building everything in an incremental fashion. And in terms of transforming this data, I will actually go into the BigQuery table to show you what's going on. And the schema looks something like this, where the primary key table is represented by the game ID. So you should have a series of unique games represented inside the games table. However, in order to prepare this for analytical purposes, let's say we want to do a player level analysis. Currently, we cannot do it in this format because we have the username and the white username and the black username in two different fields. To make it more digestible, I would like to have the username in one field with ideally a filter for the white pieces, the black pieces. And that will allow us to apply some calculations to create aggregates for a player as a collective. And you can see the performance as the white pieces and the performance as the black pieces in one record. So that's ideally what we're trying to angle for. And once we go back to the staging table, this is kind of what we're trying to do. We're unioning all of the fields inside that raw source table and we're getting the username into the same field. And this is all going to be segmented by the piece color. So that's going to be an additional dimension added to the table. Additionally, we also have these raw results that need to be processed in a more readable way for downstream consumers. So we're translating all of the results into either wins, losses, or draws, which makes it easier to provide calculations for your downstream tables. And yeah, we keep it simple for the staging player table. We don't try to do too many crazy things because we can go to the next stage where we can start changing the granularity of the table and trying to aggregate down to whatever purpose we're trying to fulfill. So if we're trying to do a player level analysis over a certain period of time, we have to start aggregating all of the metrics. So we pick the dimensions that we want to analyze, which we've selected here, and we've also got the archetype of the openings. We're averaging out the accuracy over that time frame, and we're getting the win, loss, draw count for the different games played for the various openings players are playing. Additionally, we add a couple of filters here, so we're making sure that we're looking at rated games, and we're making sure that the rule set is set to chess, and we're not looking at any of the other chess varieties in the format. And then before we finish off the process, we just pivot out the white and black performances. So we can see on a per user level, we can see the white and black performance in one record. And it makes it very easy to do data comparisons while we're analyzing it. So let's say you're playing the Sicilian defense, you can see a relative performance as white and black, and it's very clear to see what the relative win rates are side by side. So data comparisons are very easy. And yeah, we just select that data and we output into a table. Simple as that. And that's it for the DBT models. In addition to that, we also have the seeds. So what I've done is I've manually created I've taken all of the openings from the chess encyclopedia and I've manually categorized them into opening archetypes to make it easier to parse through the data and to get better aggregates in terms of looking for opening families. And that pretty much wraps up the setup for DBT. The next thing to cover is the DBT testing. In terms of testing, we have the DBT built-in tests, but we can also write custom tests inside DBT to check for other data quality components. So one thing that we have here, so we go back to models in the staging schema YAML. We have to validate that our data source is at the highest quality. So for example, the game ID, we need to make sure that the game IDs are completely unique. We should not have any duplicate game IDs inside that table. If we do, we need to go revisit the ingestion pipeline and figure out why we're inserting duplicate records into that table. And that's first things first before you even go checking downstream data quality. Assuming your data source quality is okay, you can also write custom tests. So for example here, we can check the data quality downstream. So ideally the number of games played in your source data and the number of games played in your downstream aggregate data needs to be in alignment. So that's something to remember when you're doing your data processing. You don't want to have any misalignment between your transformation steps and then what you have in your source data. Because if there is a misalignment, you will have to do some digging. Essentially, you're going to have to dig for that data quality issue. You have to check your joins, check your case statements, and check your aggregates to see if you're doing them correctly. and find out where is the discrepancy being generated. In terms of the DBT testing, we can do it locally here. So we can just simply run DBT test on our local project and see what happens. And yeah, it's going to run all those custom tests plus the built-in tests. And as long as nothing gets returned in any of those queries, you're pretty much good to go. Additionally, we can also run our DBT models locally. So we can just simply type in DBT run, and that's going to run the latest incremental model, the latest incremental period that we set in our DBT model. So just give it a moment. Taking a while. Yeah, so it's all complete successfully. If anything doesn't complete successfully, you're gonna see it in red and bold, and you're gonna have to go figure out what's going wrong. Maybe you have some incorrect references, maybe your DBT code is not compiling correctly. There might be some variable problems, who knows. So in terms of Airflow, we've got a local setup to do like a proof of concept for how you can productionize your DBT models. So in our local Airflow server, we're instantiating it with a Docker Compose setup. It's got a variety of services, including Postgres and Redis as our databases in the background. Inside our Airflow server, we define a chest transformation DAG, in which we have two tasks. So the first task is we're cloning the repo, and the second task is we're executing the models within that repo using the bash operator. So in terms of the Docker file, we're pulling in the Airflow image recommended on the Airflow website, and we're going to need two DBT dependencies. First of all, we need the DBT library to execute our DBT models, and also we need the DBT BigQuery library to execute our DBT models against our target warehouse, which is BigQuery. And those are the only two libraries you're going to need in order to get this running. So you should be good to go. And additionally, we made a variety of changes to our Docker Compose file. I'm not going to point to all of them. Essentially, we added a DBT directory where we can mount our DBT models to and execute from that specific environment. So that's dedicated for DBT. And additionally, we have a service account key that we're mounting onto Airflow, and that ensures that we have the correct BigQuery permissions to execute against the target warehouse. So that's also very important. I'm not sure if I'm missing anything else here, who knows. But we could go into the Airflow instance, and we can go into the DAGs, and this is what our code looks like. And like I said, it's dead simple. It's got two tasks that are both using the bash operator, the first of which clones the repo to your DBT directory, and we're also doing a DBT run on that target directory using the connection, the Airflow connections profile. And that's it. It's going to build into your target environment. We can just hit trigger the DAG, and we can go into our logs to see what's happening on a play-by-play basis. We'll just wait for things to execute and just verify things are working correctly inside this environment. And then if they're not, you're gonna have to go diagnose them. And yeah, I think that's run successfully. 2 check marks on both of those tasks within that run, which means nothing wrong occurred, and hopefully the data is landed inside the target warehouse correctly. And yeah, that pretty much wraps up the project. I don't know if we'll do anything else to extend it a bit further, But yeah, I think we'll just leave it at this point in time and maybe perhaps revisit it down the road if we have other ideas. So yeah, in that case, I'll see you guys later.